Okay, everybody, here we are, Wednesday class, starting here. So as you recall, we are trying to see what we can learn from the data about how much money affects political outcomes, right? And our basic trouble that we had was the trouble of multicollinearity, and it's arising because we have an omitted variable. But the omitted variable we have is candidate quality, and the basic story is that we have candidate quality that is going to affect spending, and spending is going to affect votes. But also, candidate quality is going to affect votes directly. Right? So we're leaving out a variable. We're not able to measure candidate quality. And so we're going to get biased results. Right? We have our Venn diagram. If we've got votes here, we've got spending here, and we've got quality here. Ideally, we would only want to use this blue area, right? Because that's the area where spending is moving with votes, but quality isn't. So we only want to use a certain amount of the variation in spending and votes, and we would like to leave out the red area, ideally, right? Because that's area where spending and quality are moving at the same time, and they're moving along with votes. And yeah, there's definitely an effect there, but we can't tell whether it's quality changing votes or spending changing votes. And so we would like to leave that out because we can't attribute it just to spending, right? Now, if we could do that, meaning if we had information on candidate quality, we had data on it, then that would just take care of it. We put the data on candidate quality in there, we put the spending in the regression, and the regression takes care of that. We would have big standard errors because we're only using a little bit of data to estimate the effect of spending on votes, but it would be unbiased and it would be fine, right? This would be a multicollinearity problem because quality and spending are moving together, but it wouldn't be a disaster. It would just mean our standard errors were big. We would be imprecisely estimating things because we were only using a little bit of data to do it, but we would be correctly estimating things. Okay. Yeah?
I don't think in the previous lecture there was a line that went from quality to spending, right? Quality and spending don't really votes. So because maybe then spending becomes like a scale, it will be like a second derivative of quality.
Yeah, so if quality affected spending affected votes and we didn't have this line at all, there'd be no problem. Right? Because we would just measure the spending, say, well, it came from quality, it came from wherever, who cares, right? Then we could say that spending affects votes in this way. But it's going to be the fact that we have quality is independently affecting votes. That's the problem, right? If for example, just to address your thing in Venn diagrams, right? Because Venn diagrams tell everything there is to know in the world. Right. Suppose the true thing was quality affects spending, which affects votes. That's the reality, right? But quality doesn't affect votes directly. Okay? Suppose that's the reality. Okay? Then our diagram would look like we got votes, and we've got spending, and we've got, let me get rid of that, put it in green, quality. Right? And importantly, when I do this, what should we use? We should use if we just threw it in a regression, we use this, we'd leave out this, but if we were careful about it, we could include this as well, right? And if we just put in spending and we left out quality, we would use all of this information, right? But importantly, there's no separate bit where quality is affecting votes on its own, right? So everything is going through spending. And that's what we want to know, right? If we're asking the question, how does spending affect votes? What we want to know is if, for example, we made people spend less, right? Or if we gave them money, if we had government-supported elections, how would that change the outcomes, right? We're thinking about policy. And where the spending comes from, in this case, we don't care, right? I mean, maybe we care as a separate issue, but we don't care econometrically because there's nothing that quality itself is going to do for the election other than come up with the spending. So when we estimate this, we're going to get it non-biased because we don't have this little area here. And if we include that whole thing, it's not a problem because it's still the effect of spending. The trouble we have here is not that it's wrong to include it, it's that we don't know whether that red area is the effect of spending or the effect of quality, right? Because quality has its own effect. So some of this area should be attributed to spending, some of it should be attributed to quality. We just don't know how much of each, right? But if we knew for sure that quality didn't affect votes directly, then all of it should go to spending. Now, how we would know that, I don't know. But if we did know that, perhaps a theory. Perhaps we have a lovely theory. A theorist made that for us. And so our bias comes about because we don't know which to attribute this to. Okay. And so now we have a multicollinearity problem. That's not a problem if we had the quality information, but we don't have the quality information. So that multicollinearity problem is an actual problem. We're going to get biased results. And in a minute, we're going to see which way our results are biased, right? So our multicollinearity problem comes from an admitted variable problem, and this is going to be a problem for us. Okay? Multicollinearity on its own, we call it a problem, but it's not a big deal. But the fact that we're leaving out one of the variables that's important, and it's correlated with spending, this is a problem. Okay. Now, in general, we don't know what way the bias is. Like if we have an omitted variable that's correlated with one of our variables, we know there's a bias, or could be a bias, but we don't know which way it is. But in this particular case, we actually know, right? Because what we're doing is we're leaving off this bit here, right? And we know, or at least we assume, that candidate quality is anything that makes the guy more attractive to voters, right? That's what candidate quality is. It's whatever it is that makes candidate more attractive to voters. So we know that this effect of quality on votes should be positive, right? Because we define quality to be the thing that has a positive effect on votes, right? So that's a positive effect, but we're leaving it off. And we're assuming for a moment, and this seems to be true, that this is a positive effect. And in the data, it seems to be, right, that spending increases votes, because if spending was decreasing votes on average, why are they spending in the first place, right? So politicians think it's increasing votes. We think it is, or at least vote share. Maybe he's tearing down his rival, but your vote share goes up, right? And our other thought is that quality should be increasing spending, right? Because if you're a high quality candidate, you're more likely to win. People are more likely to give you money as a bribery, right? So it's a positive effect. Your quality makes them give you more money. Also, it's a positive effect because people like you, they want you to win. One way they can help you to win is to give you money, right? And so we're thinking that a high quality candidate is going to get more money donated to him than a low quality candidate. So that effect is positive as well. So unlike the general omitted variable problem, we actually know the sign of these things, or we're pretty confident about the sign of these things, right? And so these guys are moving in the same direction. And so when we leave this out, or when we include this red area, when we're not supposed to, we know that's a positive effect that we should have left out that we didn't, right? It's this effect here. And it's moving in the same direction as this effect here. Quality goes up, increases votes. quality goes up, indirectly increases votes. Right? So they're both moving in the same direction, and we've instead of leaving that out, we've included it, which means we're getting an additional positive effect. We're getting this positive effect in our regression, but we're also getting this positive effect in our regression, or part of that positive effect in our regression. So our regression coefficients are going to look too big. In general, for an omitted variable, we know that there's probably a bias. But in this case, we know our results are probably biased upward, given that all these effects are moving in the same direction. Right? And this could be a big deal, or it could be a small deal. It depends on how big these overlaps are. Right? But if we're thinking about it, we're thinking probably this effect is fairly large. Sometimes multimillionaires run for office, multi-billionaires run for office, and they can spend all the money they want. And it has nothing to do with their quality. But most of the time, the politicians are getting money from donors. And so this is likely to be very, very much influenced by candidate quality. So it's something that we as econometricians don't observe, but everyone out there does observe. Right? And the people that are giving money do observe it. So this overlap area is likely to be really big. And it's very plausible that the direct effect of quality on votes is big as well. Like if we believe in democracy, we're really hoping it's big, right? That a good candidate's going to get lots of votes. That's the whole idea of democracy. Yeah?
Can we have a positive effect from spending money to quality, or is it only from quality to spending?
You could, right? You can think about these guys who get coaches and they get fancy suits and someone does their hair and they get speech coaching and stuff. So you can certainly imagine that spending affected quality too. It would not be wrong. Okay, I would guess, but this is, it's an empirical question, right? But I would guess that it's a smaller effect than quality on spending. But even if it was, that would be also a problem, right? Because spending affects quality, affects votes. That wouldn't be such a problem because it would be more like the last one in the sense that you throw it in, but you care about the spending. You don't care the way it goes through, right? If, for example, candidates were just blobs, amorphous blobs, and the spending of the money made them look good, right? Made them able to speak and walk and talk, and so quality totally came from spending, then this wouldn't be a problem at all, right? Because it would be spending leads to quality, leads to votes, and we'd be omitting the intermediate step. But who cares? Like the mechanism by which it works isn't what we're looking for. So if it was all that and nothing else, we'd have no problem. Okay. Yeah. Okay, so we've got our omitted variable problem, and we know that in this particular case, it is very likely, well, we don't know, but we're 99.9% sure that it means that our results are going to be biased upward. That is, it's going to look like spending has more of an effect than it really does, right? Because we're leaving out the candidate quality. So what people did in the literature is they tried very hard to deal with candidate quality as best they could. If you think about it a bit, it's really hard to think what is a measurable thing that says candidate quality. But they do their best, right? And as they do better and better at this, the estimates they get go down. And it looks like, if they just throw in spending, it looks like spending has a very big effect on election outcomes. If they control for candidate quality a bit, that number comes down, but still fairly high. Okay, and now we're to Mr. Levitt. And Mr. Levitt's going to deal with this in an interesting way. Now, I will say that I'm not a big fan of this paper, or most of Mr. Levitt's papers, but it's very clever. And most of his papers are very clever as well. So it's an introduction to Mr. Levitt. Okay. All right, so the way he's going to do this is he's going to think, okay, candidate quality clearly matters, and we're never going to be able to measure it very well. But every so often, we see that two guys go up against each other for election, and then they go up for then one guy wins. And then the next elections, the same two guys go up against each other again. It doesn't happen all the time, but sometimes someone does well enough or that he was close and he comes back and he tries again, right? So if we have the same two guys going up against each other this year and 2 years ago, right, we can imagine that their quality didn't change very much in 2 years, that they're the same weirdos that they were 2 years ago and now. And the only real difference is that the spending is maybe different. And so that's going to be his insight. He's going to say, rather than looking at everybody who ever ran for Congress in this case, ever ran for Congress, we're going to limit our set to just the times when the same two guys came up against each other. And as you can imagine, this is going to be throwing out most of the data because most of the time it's not the same two guys, right? You're a loser this time, they don't put you up next time because why? You're a loser, right? And so it's different guys each time. Maybe one guy is the same, but both of the guys aren't the same, okay? Okay? And so the central conceit of this thing, well, there's two sort of central conceits that make this work. The first one is important, is to think that like literally, they have exactly the same quality that they had the first time they ran. They didn't become better at their job or anything. Now that's probably not literally true, right? But nothing in empirical work is ever literally true. So the central conceit is more that they're more like these two guys this time and last time are more alike than two randomers put in there, right? And so the quality, maybe it doesn't stay exactly the same, but it stays about the same, more or less. And so the variation in quality between these two guys is not too big, okay? So if you buy that, here's what it's going to get you to do. Let's suppose that this is the reality. Oh, sorry, I'm missing a bit here. Right? That's the reality. Now, there's going to be other stuff in the regression as well, but we want to focus just on the important bits. Right? That this is how elections work. The amount that people vote for you depends on an alpha, which probably has to do with your party or whatever. I get some base level of voting. And then it depends on linearly on how much you spend and the quality of you as a candidate. And here we're really thinking how different in quality you are from the other guy. Right? You're going to get more votes if you spend more than him, and you're going to get more votes if you have higher quality than him, and less votes if you have lower, right? So we're thinking this is really the difference in the quality between the candidates, right? Okay. So then let's put time subscripts on here. Let's call this T, 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 right? So that's at an election at time T, say 1980, right? There's an election at 1980, T is equal to 1980. And this is the votes in this particular election. Votes in 1980 depended on the difference in the spending between the two guys in 1980 and the difference in quality in these two guys in 1980. And then we can say, well, if these two guys, if these are just two random guys, there's nothing we can do about that quality thing. But if these two guys also ran against each other in 1978, then there's something we can do. Right, we can write the equation for 1978. If this is reality, Vt minus 1 is equal to alpha plus beta 1 spending in T minus 1 plus beta 2 quality in T minus 1 plus whatever the random shock was in T minus 1. Right? So these are the same two guys that came up against each other twice, once in T minus 1 and once in T. And now, what I can do is I can subtract. Right, if that's the reality, I can subtract the second line from the first line. And that gives me Vt minus Vt minus 1 is equal to alpha minus alpha plus beta 1 spending in time t minus beta 1 spending in t minus 1 plus beta 2 quality in t minus beta 2 quality in t minus 1 plus et minus et minus 1. Right. And then I can say, well, I got these spendings. And the beta 1s are the same here and here. Beta 2s are the same here and here. So let me write it this way. The change in Vt is equal to beta 1 times the change in spending plus beta 2 times the change in quality plus et minus 1. Right? Just saying, we're going to look at the difference between the 1978 election and the 1980 election. How much was spending different in those two elections? And how much was candidate quality different in those two elections? And we can run this regression. But of course, if we have these repeat challengers, this would be 0. Right? If we really believe that they didn't change their quality over time at all, right? That is the same guys in 78 as they are in 1980, because we're using these repeat challengers, we can say, well, that's probably not literally 0, but it's reasonably close to 0. They're the same sort of guys they were before. Now, it could be that over that time they learned some speaking skills and they got advisors and stuff, so it's probably not literally true. And maybe the guy that did get elected, he got better at his job over time, like maybe. Maybe he got worse, who could know? But it's probably not literally true, but it's probably more true than if we just had a new random guy, right? So the difference in quality, even though we're leaving out this difference in quality by pretending it's 0, it's probably not 0. It's probably much, much smaller than quality was in the beginning. Right? Variation between these two guys is probably much smaller than variation between two random guys. So this quality thing is going to, we're still emitting something, but we're emitting something really small that probably isn't as big a deal as it was before. That's the central conceit of the thing. Okay? Now you can buy that or not. And he's going to go to great lengths to try to convince you of that because this is important to him, right? But you can buy it or not. But that's the central idea. And so then the reality becomes the change in Vt is equal to beta 1 change in St plus, I don't know, we use some other Greek letter. What other Greek letters we got? I don't know. I forget all my Greek letters. Look at that one. Right? This is our new shock, which is just the difference between those old shocks. And that's reality. That isn't given that we started that the reality was as simple as that, then it becomes this, and quality just disappears if we're using these repeat challengers. And we can run this regression, and we have no major biases. We got that. Maybe it's not truly 0, but this beta will be much better estimated than it was if we just ran the first line as a regression. Okay? Because we've gotten rid of this candidate quality as an issue because we're using these repeat challengers. Okay, people with me here? Okay. So a few sort of housekeeping bits. He is using, what years does he use? It's something of an interest. Just to see how empirical stuff works. He uses, it's an old paper, so he uses (1972 to 1990) congressional elections. Okay. Now, it's worth talking about why he does this and what we should think about the fact that this is what? 30 years old data at this stage. Okay, so 2 issues there. Now, first of all, in terms of it being 30 years old data, people have updated this and you still get basically the same results. But there's reason to think that 30-year-old data might actually be better than current data for this. And that has partly to do with the reason he's using US data. And the reason he's using US data, as I mentioned before, is that US has pretty good data, or had pretty good data, on money in politics. Right? Because in 1972, with the Watergate hearings, they put in the requirements that everyone report the money that they're spending and the money that they're raising. And so he can't do it before 1972 because there's no way to get the data. No, people weren't reporting it. People were doing it all. And they weren't even thinking about it as under the table, but it was effectively under the table. There's no way to measure how much they were spending before 1972. So they got to use 1972 and later. And congressional elections are important because these guys go every 2 years, because we need lots and lots of elections because we can't use all the elections. We can only use the ones where we get the same 2 guys coming up. So we need tons of elections so that the same 2 guys come up often enough that we have some data. Right? And so you couldn't use US Senate elections, which only happen every 6 years and only happen for 100 guys. It's much better to use these elections that come up for every 2 years, and there's 470 guys. So there's much more likely to get repeat guys coming up. Okay? Now, just to give you a bit of the jargon that goes around in politics these days, what he's going to be able to measure is what's called hard money. And this is something that was defined in the legislation about what they had to report. So if somebody gives a politician or his political action committee, his little corporate entity, if someone gives him money, he has to report that. Okay? And then he can spend it in any campaign-related thing. He can't buy himself a house, although some of them do. But legally, he can't buy himself a house, but he can spend it in any campaign-related stuff. And that's defined pretty broadly. He has full control over this. Okay? And this is called hard money, and it's something that's totally in his control. Okay? There is also, as you might imagine, because we love to name money, there's something called soft money. And at the beginning, and this is unmeasured, at the beginning, when the legislation first came in, I think in the 70s, people were still figuring out how that worked. And so the vast majority of money that people gave to politicians in the US was given to the politician, right? You want to curry favor with the guy, you give him some money. You want to help him get elected, well, give him control of the money so he can use it in the best possible way. But there's limits on how much you're allowed to give. Right? It's not a limits on how much he's allowed to spend, but there's limits on how much you're allowed to give to him. And so what happens is that over time, people get better and better at getting around these limits. And they do that through what's called soft money. Okay? So I'm not going to give money to the politician, but I'm going to give money to some other guy or some other organization, and they're going to take out ads in support of the politician. Okay? And so here, the politician doesn't have direct control of the money, but I'm still pretty much using it for him. And if people will go to the politician and say, I want to give you $50,000. And he says, well, the limit is $5,000, so please give me $5,000. And then you could give, I don't know, do what you please, but you could give $45,000 to Joe. He's a good guy, and he's got a political action committee set up, and he does causes that are near and dear to our heart, whereas really Joe's his cousin, right? And they still use the money to affect the outcome of the election. So this is soft money. It's sort of a way around the campaign finance legislation. And it's illegal to have control over that, so it's kind of illegal to be telling Joe what to spend the money on, but they do their best, right? Now, it's also possible you can give soft money, and a lot of soft money does go to saying, well, I don't care about any of these politicians, but I would like this issue addressed, right? So I want, whatever. I want some issue addressed, and I'll give money to an organization that's committed to that issue. Now, usually it's not that hard to figure out what politician that issue is related to, right? And so, they give money to a particular cause, Save the Whales, and then the Save the Whale people come up with lots of ads. It's usually pretty clear what politician they support or don't support. But importantly, the politician doesn't have control over this money. And sometimes it happens that the politician is, say this year, the politician is anti-abortion, but would really not want to bring that up because people are mad. And so they would like the anti-abortion guys just be quiet this one, right? But those guys are, even if they have the money, they're going to make it loud and proud. So the fact that you're giving to someone who's on the same side as the politician, it doesn't mean they're always going to spend it the way that the politician wants. Okay? Now, importantly for us, this is just the jargon, the soft money, but they've gotten better and better at getting around the law. So in the early days, soft money wasn't even a thing. And since 1990, it's become a bigger and bigger and bigger thing. And nowadays, I think soft money is huge. Now, we can't measure it, though. And so all we're going to be able to measure is the hard money. And so actually using the earlier data and not using the more recent data is not as bad as it sounds. Now, you get basically the same results if you use the new data. But still, because soft money wasn't such a big deal back in the day, it gives you a better idea of how money affects politics. But of course, it only tells you how money affected politics 30 years ago. It doesn't tell you how it affects politics now. Right? And the one other, while we're here, that we should talk about is dark money. And this is soft money that's given to somebody without anyone's name being attached to it, that goes into entities that don't have to report. So a lot of these soft money entities are actually governed by the political campaign finance regulation, and so we can see how much soft money there is. We don't know who it's for or how effective it is, but we can see how much there is, and it's gotten huge, right? But there's also money where people give to organizations that do not need to report. And these have become much larger by all accounts, but we just don't know how much is there. It's like dark matter. You can see its effect on things, but you can't really see it itself. It's the same idea, right? Okay. So we're going back in time to 1990 and earlier, mostly, well, because that's all he had at the time, but because hard money was basically the only sort of money that was in the political system in large extent up till 1990 or so. And there was some, like, in the 80s it became a thing. Yeah?
Could you please repeat the difference between soft and dark money?
Yeah. So if I have a political action committee, so this is all just legislation based. It's nothing like fundamental, but because of the legislation, there's limits on how much you can give to various entities. And because they've limited the amount that you can give to various political entities, they want those entities to report it. So if you give money to the politician directly, that politician has to report how much you gave him, what he spent it on, and who you were. Right? So for example, as an Irish person, you can't give money to an American politician. They won't accept it. Well, they shouldn't accept it. Right? And so they need to document that it's not foreigners influencing our election or anything. So your name will be attached to it. Soft money is a regulated entity, but it's not in control of the politician directly. It's in control of some political group. And so you can give another $5,000 to this group, right? So you can give it to, for example, the Republican National Committee, and they can spend it on whoever they want or however they want to spend it, right? And then again, the politician won't have direct control of it, but he still might be happy you did it, right? And so you're still currying favor with him. You're still helping him get elected, but we can't tell what it's being spent on. Maybe it's being spent to help you get elected. Maybe it's being spent to help someone else get elected. We can't tell, right? But that's reported and your name's attached as well. Okay? With soft money, you're giving it to something that's not falling under the regulation. So maybe it's a corporation that set up a limited liability corporation. But they're going to do political stuff with it too. They're going to do their anti-abortion ads or whatever, right? And you gave to them. But that's not reported. And so nobody knows how much money they got. Nobody knows how much money they spent. Nobody knows who gave them the money. Okay? And that's dark money, that we just can't see it. Okay? So we could, if we wanted to take into account the modern way of doing stuff, right? We could do our best to include soft money, right? Because we know how much of it there is. And we could go and we could try to figure out, okay, here's an anti-abortion PAC, how much do we think they spent in Arkansas? And what candidate do we think that is supporting, right? There'd be a bunch of suppositions in there, but we could probably do a reasonably decent job if we were careful. Right? More work than I'm interested in doing, but we probably could, right? Be a bunch of judgment calls, like here's an anti-abortion thing, which candidate are they supporting, where are they spending the money, all of that, we don't have that detail. Right? They spent so much on ads, we have to guess where those ads were and which candidate they supported, but we could probably get a pretty good idea. The dark money we'll never know because it's unseeable, right? It's dark, yeah.
Are there estimates that what percentage of money is each?
Yeah, so soft money we know because it's reported.
Is there an estimate like, oh, actually 30% of all candidate money is actually dark or something?
There are people who do that, and I want to give you a number, but I can't because I don't remember numbers. It's right over. But it's getting larger and larger by all accounts. It's a bigger and bigger deal. Like they've gotten better and better at working around the finance legislation. And also the legislation's been progressively weakened over time, so it's easier to get around it. So it's a significant and important bit now, whereas in the 70s it wasn't even a thing. Soft money wasn't even really a thing in the 70s. It existed, but it was very small. But now soft money is huge, like hugely important. But there are numbers, but I don't have them. Right. Now, soft money can be a blessing or a curse, right? Like, they can bring up things that you don't want to because they're interested in usually an issue rather than a person. But also they set up soft money entities specifically to help a person as well. Right? So this is the thing. So going back in time and looking at the old days, while they are the old days and the new days aren't necessarily the same, isn't too horrible from a sort of a data perspective, that the hard money was a much bigger deal back in the day, much more relatively important than it is today. And so since we can measure it then, and this is not a bad baseline to start with, but when you do things in the modern era, it becomes less and less convincing. Now, you can still do this same exercise in the modern era, and we get sort of similar results, but it's not clear how complete those results are because we're typically leaving off soft money and definitely leaving off dark money. Okay. Okay, so he's got all these elections. He's got them, if I can get the actual data. And that gives him, from these dates, it gives him 2,781 elections. That's 470 guys over what? 18 years, 20 years? I think 20 years, right? Over 20 years, every 2 years they run for office. Now, sometimes a politician gets hit by a bus and they have to have a special election. Sometimes, and you can see there's a footnote in the paper, sometimes they get caught in a bathroom soliciting underage boys, and they have to have a special election. There's all sorts of things that happen, right? It's a mess, and you have to deal with that. So one of the downsides of using congressional elections is that the districts change every 10 years, and so they redraw them. And so you could be a great candidate for Atlanta, but all of a sudden in the next election you're out in the rural areas, right? And you're a terrible candidate for there. And so you have this problem that even if your quality is a good candidate for a particular set of voters, right? It's not cast in stone. And if you change the set of voters, it's not clear that the quality is the same, right? A guy who is a good candidate for urban voters can be very different from a guy who is a good candidate for rural voters, and they can change your district over time, congressional elections. Okay? So that's a problem he has to deal with. And so he gets rid of people that have the scandals, and he gets rid of people that, that are just really clearly outliers. And then he finds the people that have the elections where they have repeat challengers, and he gets 633 elections with repeat challengers. What were repeat candidates? Not just where the challenger is the same, but where we get the same two guys coming up against each other multiple times, which is pretty large. Like, I was kind of shocked how big that is compared to the total number of elections. Like, the same two guys come up against each other reasonably frequently. Like, I had no idea. Like, I knew it happened, but okay, it's a thing that happens reasonably frequently. But of course, we can't use all that, because what we're going to do, if we can go back here, is we are going to difference them. Right? We need to take the new election and we need to subtract the old election to be able to do this kind of thing. So we can only use about half of them. And so he gets out of that 334 usable pairs, triplets. Okay. Now you would think two things that I would think, I don't know what you would think. First of all, why is this odd? It's an odd number here, right? Like, we have elections with repeat challengers, like, shouldn't that be even? Well, it turns out, no, it shouldn't be even, because mostly you have these repeats where it repeats once, but sometimes they meet up with each other 3 times. And in a few cases, 4 or even 5 times that the same two guys meet up with each other. Now, he throws out all the ones that are 4 and 5 times, thinking, those are just weird. There's just something weird about those same two guys meeting up 5 times. Like, what the heck? That's the person's entire adult life, right? If 5 times, it's 10 years. 10 years every time they're meeting up. They're just a bunch of weirdos, so let's get rid of them. But he does keep the ones where it's 3 times, right? Which is why this is not exactly half. It's a bit more than half, because there's these times when the guys meet 3 times. Okay. Okay. Now his regression, so his data points, like in his regression, he's going to have 334 pieces of information, right? So he went from 2,700 to basically a little over 10% of that, right, by doing this. So he's throwing out lots and lots of data, right? Which data is he throwing out? He's throwing out all the data of people who didn't meet twice, because we're using the fact that they met twice or more. So all the data that people didn't meet twice, we just throw it out, binned, okay? Wasted data. And we're also throwing out half of the data because we're doing this subtraction, right? So instead of having 2 elections there, we only have 1, really, the difference between the 2. So we threw out loads and loads of data, and we're left with basically 10% of the original data. But the hope is that by throwing out 90% of the data, we're going to have information that doesn't have this quality bias problem, right? And so, yeah, we're losing lots of data, but we're gaining this, assuming you buy his conceit that these guys keep the same quality, we're gaining this understanding of the effect of spending without the effect of quality. Okay? So there's a benefit and a cost. Right? It's not cost-free. We lost 90% of our data. That's 90% of the information that's going on here. But the benefit is we're going to deal with this omitted variable problem, okay? Given that you buy the conceit. Very clever conceit, by the way. This, by the way, is very similar to how they do lots of labor stuff when they use twins. They always have like the, is it nature or nurture right, that affects whatever. Like, why am I a criminal? Well, it's probably because it's in your genes. Well, what we can do is we can get my twin, and he got raised differently than me. And I got raised in a bad way, he got raised in a good way, and I robbed a bank, but he stole the entire, anyway, don't get me started about my twin. He's the evil twin, clearly. But they do the same thing, right? Because the sort of genetic quality is the same, they can difference that out, and they can see the effect of other things because they're using something where the genetic bit is the same. Here we're having the candidate quality bit being the same, and use that to get at other things. So just when you do a twin study, and there's loads of them in psychology, loads of them in economics, you're throwing away all the people who aren't twins, right? So you're throwing away the vast majority of the information on people because you want that to get rid of that one particular thing, which is the genetic component of things, right? Here we're trying to get rid of the candidate quality component of things, and to do that we throw out lots of data, just like we throw out the non-twins. Okay? It doesn't mean that you should always throw out the non-twins, but it's useful to, from time to time, look at the twins, then compare it with the rest of the people. And that's going to be a similar sort of thing here. Okay. Okay, now I will say if you take a look at the paper, which you should, just skim. Like, don't try to go through everything. Don't try to understand all the equations, but skim, get an idea what an empirical paper looks like, because it's a well-written empirical paper. If you look through it, his equation looks very much more complicated than my little equation. And that's because he's trying to deal with lots and lots of stuff. He's trying to deal with, for example, are you an incumbent politician, somebody that already holds the office, or are you a challenger to an incumbent politician? Because there's a lot of evidence and a lot of stories suggesting that incumbent spending is going to have different effects than challenger spending, right? Because the story here, empirically it seems like, or up till this time, it seems like spending by challengers has more effect on votes than spending by incumbents. And we can easily tell a story for why that is, right? You could think, for example, that an incumbent guy, a guy that's been a congressman for the last 20 years, right? Everybody knows him, right? He's been around for ages. You either hate him or you love him or whatever, indifferent to him, but you know who he is. And so if he spends money, it's not really going to change your opinion of the guy because you have a 20-year history with the guy. You have opinions already formed. And so his spending will probably not be really super effective. But a challenger, somebody you don't even know, well, he has to introduce himself to you, right? And so he has to get his face out in front of you so you could learn who he is, right? And so that spending might be much more effective because your opinion isn't totally formed, okay? And so empirically and just in story, we think like whether you're a challenger or an incumbent very well might matter for how effective spending is. So he has to like deal with that in here. He has to deal with, also sometimes it's an open seat, right? The congressman, he gets caught in the bathroom, soliciting the underage boys, and he's carted off to jail, and that's all well and good, but now someone has to be the congressman from that district. So we have two guys, neither one of which is an incumbent. They're both somehow challengers. So he has to include that as well, because that's different than being a challenger to an already existing guy, right? And he has to deal with the fact that some districts are Republican districts, and Republican districts are probably always going to get more Republican voters, all else equal, than a Democratic district. So he has to include that as well. And he has to, what else? There's a few other things he includes. And then he has to put in all the characteristics of the district. And some years are just Republican years, and some years are just Democratic years. So he has to put in time stuff as well. So if you look at his equation, it's going to look way messier than this, but fundamentally it's just this. It's just different ways to include all that stuff in there so we can just run one regression and then capture all that stuff. Are you an incumbent? Are you a challenger? Is it an open seat? Right? All of this kind of thing. And the fact that you might have been a challenger the first time, but the incumbent the second time. Or you might have been an open seat the first time, and then, right? So you have to include all that stuff in there, and it just makes it look messy. So don't worry about the fact that it looks messy. It's just his way of including all that stuff. It's really just this. Okay. Yeah, let me save this before it's gone because I know you guys are going to want this. And let's go to the paper itself. All right, so the paper is explaining all of this, and the introduction is good. You should read the introduction. 2 pages, 3 pages, something like that. All right, poor little. And here's his little version of the thing. We want to go to his first table, which is page somewhere. It talks about the data, same thing I did. Here we go. And the reason I want to work you through his tables is because I want you to, when you read a paper, when you look at a paper, or in fact anything, how are we doing? I got to let you go. Okay, we'll look at the paper and look at anything next time. And yeah, have a good weekend, and I will see you on Monday.